Today we're beginning Unit 4, which is triangle congruence. And today's lesson is specifically an introduction to congruence. So before we start, we're going to compare some things. We're going to talk about similar shapes versus congruent shapes. So this unit, or the next 4 lessons or so, are on congruence. And then after that, we have an entire unit on similarity. So they do have some common traits between the two, but they are two different terms. So we're going to take a moment and explore the difference between the word similar and the word congruent. So similar figures are the same shape, but they are not the same size. Two shapes are similar if their corresponding sides are proportional. That means that the scale factor, which we learned about last unit, has to be the same throughout the entire figure for a figure to be similar. But in general, similar figures are not the same size. They are only the same shape. Whereas congruent figures, which is where we're going to spend most of our time, congruent figures are exactly the same shape and the same size. So in the past, or in the last unit, we talked about rigid motion. Congruent figures would be rigid motion, or an example of a rigid motion, because the shape and the size do not change. So two shapes are congruent if their angles are the same measure and their sides are the same length. And also two plane figures are congruent if and only if they can be obtained from the other by rigid motions, like I just mentioned. So we use certain symbols for congruence and similar figures, but today again we're just looking at congruence. So we should all recognize the congruent symbol at this point, but the congruent symbol looks like an equal sign with a squiggly over it. And this symbol indicates that two figures are equal in size and similar in shape. So if I go back up to these boxes above, the similar symbol is just a squiggly line like this, or squiggly mark, whereas a congruent symbol is an equal sign and then that symbol on the top. All right, looking at the first example, the directions in the set say to use the definition of congruence in terms of rigid motion to determine whether the two figures are congruent and explain your answer. So congruent means same shape, same size. So if we look at number 1, hopefully you automatically recognize that these two figures are not congruent because they are clearly not the same size. So no, the figures are not congruent. They are not the same size. Number 2, however, number 2 does look like these two figures are congruent. So if I compare the different points, so if I compare trapezoid JKLM to the figure PQRS, it appears that this figure just shifted in the coordinate plane. It appears that it made a translation. And that yes, it is in fact a rigid motion, so these are congruent figures. Yes, these figures are congruent. That should say are congruent. If I was to write a translation rule for this and we were mapping JKLM onto PQRS, It appears that the shape shifts 5 units to the right and 3 units up. So I could write my rule as x comma y maps onto x plus 5, y plus 3. And again, these figures are congruent, these figures are not. Next, we're going to take a look at two congruent polygons, and we're going to talk about the different parts, so the angles and the sides. Right here it states that two polygons are congruent if and only if their corresponding parts are congruent. So that's again talking about the angles and the sides. And recall that you should know about corresponding angles and corresponding sides from previous lessons. If we look at the angles, you can always tell by the angle connector. So angle B and angle J are congruent. I'm just going to write a couple of these down. I'm not going to write them all. You can come back and add them in if you want to. But angle B is congruent to angle J. We know that because of the angle marks. You can see that A is congruent to, H. Actually, you know what? Let's write them all down. Angle B, angle J, angle A is congruent to angle H, and lastly, angle C is congruent to angle K. So not only are we looking at angles, but we can also look at sides, and we know that by the angle connector, or the little angle mark, this one here. We match the number of them. So the two sides I just highlighted would be AB and HJ. Make sure you're consistent with the order. So I went from angle A to angle B when I labeled that segment. So we need to do the same thing on our other figure. So I'm going to go from H, which corresponds to A, H to J when I'm labeling my figures, specifically when I'm labeling my segments. Next, we're going to look at BC. I see that these are congruent because of the two angle connectors or two angle marks. So BC is congruent to JK. And the last one is AC is congruent to HK. And I see the three connectors. So angles are obviously written in the correct form of an angle, and sides we label them as segments because sides of a figure are segments of a line. If I was to write out a congruent statement, I would write this as triangle ABC is congruent to triangle HJK. And again, make sure that when you write this, your parts correspond. And when I'm talking about parts, if I look at this statement, angle A should correspond to H. Just double check to make sure that's correct, and it is. Angle B should correspond to J. That is also true. And C should correspond to K, which is true. So this order matters. For the next example, it says show that the polygons are congruent by identifying all of the congruent corresponding parts. So we have Figure HIJK is congruent to LMNO. What are the congruent corresponding parts? Now, we're going to label all our sides and all our angles. You can either do that from the figures, or you can do that from the congruent statement. And if we do it from the statement, you're just going to match the parts. So, for example, the first two letters, HI, is going to correspond to LM. And I can check that right here, HI, LM. And that is true. After I do HI and LM, I can do the next two letters, which would be IJ and MN. IJ, MN. After that, we can look at JK and NO. And the last letter is going to be, or the last segment is going to be the first and the last letter. So if we have H, K, and L, O. If I compare that on here, HK and LO. All of those sides are congruent. So again, you either do it from the statement or from the model, but either way, you're going to get the same answer. You have to make sure your corresponding parts are lined up when you write out your statement. Now we can do the same thing for the angles. So let's start with angle H is congruent to angle L. Angle I is congruent to M. Angle J is congruent to angle N. And lastly, angle K is congruent to angle O. If I want to mark these in my figure, I know that H is congruent to L. I use one connector for those, or one angle arc. I know that angle I is congruent to angle M. I'm going to use two arcs. I know that J is congruent to N, three arcs. And the last one is K is congruent to O, which I'm going to use four arcs. For the next question, we are asked to identify the congruent corresponding parts of triangle WYS and MKV. So I did not give you a model for number 2. You should be able to work right from the statement. So I'm going to start with WY and MK for sides. Next we would have YS and KV. And lastly, you'll use first and last letter, so W, S, and M, V. And I don't know if anyone else caught this, but right here in the second one, I just labeled the wrong letter. It should be YS is congruent to KV. All right, we're going to do the same thing with angles. And for the angles, we are going to put the corresponding angles together. So W corresponds to M. Angle W is congruent to angle M. Y is congruent to K. And lastly, angle S is congruent to angle V. So there's 2 on your own questions. I would like everyone to press pause on your video, complete the on your own questions by yourself, and come back and check your answers against mine. So next we're looking at another theorem, which is called corresponding parts of congruent triangles are congruent, and we abbreviate this as CPCTC. That way we don't have to write that whole statement out every time. So CPCTC states that when 2 triangles are congruent, then corresponding sides and corresponding angles are congruent. So you don't have to have all of these marks on here. What you need to know, or what you need to have, is the statement that says triangle ABC is congruent to triangle DEF. Okay, and by having this statement and having this theorem, you automatically know that all angles and all sides are congruent. So for the first example, it says to use CPCTC to identify the missing values. In the diagram, triangle ABC is congruent to triangle DFE. That means we know all angles and all sides are congruent. We need to find the values of X and Y. So I'm going to notice that right away, angle B and angle F are congruent based on the statement, so B and F. Also, we know that the angle measure of angle B is 99, whereas F is 8y minus 5. So we can easily use algebra and the fact that these 2 angles are equal in order to solve for y. So first I started noting that they are congruent, and then in this next step I just turned it to an equal sign. Also, don't forget when you use an equal sign, you need to use your little measure symbol. From here I'm going to use substitution, which I substitute 99 for angle B and 8y minus 5 for angle F. I'm going to add 5 to both sides. 104 is equal to 8y. I'm going to divide both sides by 8. And my final answer for y is equal to 104 divided by 8, which is 13. That's my solution for the y variable. Next, it looks like we need to solve for the variable x, which is located here. I know that BC is congruent to FE. I know that because of the statement that we are given, BC and FE, they are congruent sides. I'm also going to have to use my value for y in order to solve for x. So I know that segment BC is congruent to segment FE, and in turn I know that segment BC is equal to segment FE. I can then substitute my values in. I can substitute 38.4 for BC, and I can substitute 2y plus x for FE. For the next step, I'm going to substitute in my value of y. I have 38.4 is equal to 2 times 13 plus x. And now I'm just solving for x. So 2 times 13 is going to be 26. I'm going to subtract 26 from both sides, and my solution is x equals 12.4. And that's my final answer for x. For the next one, we don't have diagrams, but we do have a congruent statement. The statement says that triangle WSY is congruent to triangle MKV. Angle W is 62, angle Y is 35, and we're looking to solve for angle V. So I am definitely a visual person. I think that in this case, it would be helpful for me to sketch a triangle. Now, it doesn't have to be perfect, just sketch a triangle, something that you can label. So we actually want two of them because we have two congruent triangles. One of them I'm going to label as WYS. The other one I am going to label as MKV. I know that angle W is 62 degrees. I know that angle Y is 35 degrees. I don't know what my third angle is. But in my other figure, I know that M corresponds to W. I know that K corresponds to Y. And V corresponds to S. So I'm going to start by using the triangle angle sum theorem with this figure here. So we know that the measure of angle W plus the measure of angle Y plus the measure of angle S is equal to 180 degrees. We also know that W is 62. We know that Y is 35. And we can easily solve for the measure of angle S. 180 minus 62 minus 35 gives us the measure of angle S at 83 degrees. That means this angle here is 83. I also know, based on CPC/TC, that angle S is congruent to angle V. Therefore, the measure of angle S is equal to the measure of angle V. We just solved for the measure of angle S. It is 83 degrees. 83 is equal to the measure of angle V. This is your answer. Of course, you could switch that around and say the measure of angle V is equal to 83, but either way, this is the same final answer. And again, I think that it is helpful to draw a model. I would most likely do that on a problem like this. And for the last example set, we are finding congruent triangles. So we are determining if the triangles are congruent. If so, we need to justify our answer. So if these triangles are congruent, that means we need all sides, all corresponding sides, and all corresponding angles must be equal. So let's start with sides. We'll do all the sides in orange. So right away I see that I have these sides that are congruent, and I also see that when I'm labeling them, E and A are congruent. So I'm going to start by labeling AC congruent to EC. I'm also going to recognize that AB is the length of 3 and ED is the length of 3. Because they are the same length, they are also congruent. So I can say AB is congruent to ED. And lastly, I see that BC is equal to DC, both of the length have the length of 4. So I can say segment BC is congruent to DC. So here we just proved that all sides are congruent. Let's take a look at angles. So right away I see angle A and angle E. I also see that angle B is a right angle, and so is angle D. So I'm going to use angle B and angle D as two congruent angles. And then right here, be very, very careful with these. You do have vertical angles. So while these are vertical angles and they are congruent, I just marked them, you cannot label them as angle C. So this side, this angle, is going to be labeled, or I am going to label it as BCA. Remember that because angle C references multiple angles, you cannot use it to actually name an angle. And then the opposite side over here, if I labeled it as BCA, then I need to label the next one as DCE. But we just proved that all angles are congruent. So therefore, by CPCTC, corresponding parts of congruent triangles are congruent. We know that triangle ABC is congruent to triangle EDC. This right here is your congruent statement, and that is part of your final answer. So do not forget to include the actual statement. For number 2, we're looking to see if corresponding parts are congruent. And right away, I need you all to notice that your congruent sides are within the same triangle. They are not corresponding sides to a different triangle. they're only congruent to themselves. There's no other indication that they are congruent to one another. So right away, I need you all to recognize that you cannot prove this to be congruent. We do have side lengths that are congruent, but they are within the same triangle. They are not congruent to the corresponding triangle. Okay, I'd like everyone to press pause again. Please try to complete the on your own section by yourself, and then come back to check your answer. If you have any questions or need any help on this lesson, please let me know. Otherwise, have a great day.